Okay, we're back once again to talk about two more tests, two at a time this time. This time we're talking about the two different styles of comparison tests. First, there's just the straight comparison test. And what goes on here is if you have two series, AK and BK, some of the AK, some of the BK, and if you can put 0 between AK, between BK, for every single term in AK and BK, if you know that BK converges, then AK converges also. If 0 is less than BK is less than or equal to AK, so now you've stuck the BK between the 0 and AK, so you know each AK is bigger than each BK. And if BK diverges, then you know that AK diverges. Alright, let's go ahead and do an example with the comparison test. Here is the sum k equals 1 to infinity of 1 over k squared plus 4. Well, every single term of 1 over k squared plus 4 is strictly less than every single term of this series 1 over k squared. So this is the AK we were given, the series, and I'm going to provide these as my B series. Well, I know that the series of B's converges because it's a P series with that greater than 1, it's 2. So that means this also converges by the comparison test. Now, as you know, we could directly prove this with the integral test also, but we were discussing this in class the other day, and I think this makes a decent amount of sense. All right, the next thing that we're going to look at is the limit comparison test. So again, you're given a series of AKs, you're going to provide a series of BKs, and we're going to look at the limit of the ratio of AK to BK. If this limit exists and is finite, then they both do the same thing. So if you provided a series BK that converged, and then this limit is finite, then AK converges also. But if you provided a BK that diverged, and this limit exists, then your AK also diverges. If this limit is 0 and your BKs converge, then the AKs have to converge. However, if this limit is infinite and the BKs diverge, then your AKs also diverge. Let's look at a use of the limit comparison test. I think on this one I accidentally wrote my limit upside down one time, so I did BK over AK instead of AK over BK, but let's take a look at this. So we're given, this is our series of AKs. So each AK looks like k squared plus k minus 1 over k to the 4th plus 4k squared minus 3. We have to provide a series of BKs. Well, this thing reminds me a whole lot of 1 over k squared, which I know is a convergent P series. So I'm going to compare these terms to the terms of 1 over k squared. So what I need to do is look at the ratio of those and its limit. So I'm looking at the limit k goes to infinity of AK over BK. Well, if you divide AK by BK, that's the same thing as multiplying AK by k squared over 1, which means we're going to get k to the 4th plus k cubed minus k squared over k to the 4th plus 4k squared minus 3. Well, that limit is 1 because we just end up at the ratio of these front coefficients here. So that limit is 1. So if we go back to our test for the limit comparison test, our limit exists and our limit is finite, so both of these series do the same thing. So since we provided a BK that converges, then our AK series also converges because they do the same thing. So our series converges. Alright, that is it for comparison tests.